Hello students, in this video we are going to discuss application of Z transform to solve difference equation. So difference equation is a equation contains difference of a variable. So it's based on concept of finite differences. In signal system, the time is when the time is in discrete, Z transform is applied to find the frequency. So, but Fourier transform all in a continuous time interval that apply. When you have the time is in discrete, for example 1, 2, 3, it is not continuous. Okay, there the Z transform helps to solve the converting time to frequency domain. We follow the procedure to solve difference equation. Firstly, we should know that first order difference equation contains highest term is yn plus 1. Second order yn plus 2. Likewise, it will continue. So, if they given the difference equation containing this type of terms, we take Z transform on both the sides of the given difference equation. For that, we need to use the shifting property. You already know that. So we use Z transform of un or yn is u bar z. If it is given yn, we write y bar z. And Z transform of un plus 1 is equal to z in the bracket u bar z minus u naught. So when you have after n, if you have 1, it is z power 1. If it is 2, it is z power 2. In general, shifting property is written as Z transform of un plus k is z power k. So based upon this k value, u bar z minus u naught minus u1 z power minus 1 minus u2 z power minus 2. Like this it will continue. We have to stop at Z transform at the end. You have to start u k minus 1 z power minus k minus 1. See, if it is 1, we have to take z power 1 and k is 1, where it will end when you have here k minus 1, u naught and z power 0. So it will end at u naught. That is what Z transform of un plus 1 is z u bar z minus u naught. Similarly, un plus 2 will end here. Un plus 3 will end to u2 z power minus 2. So it's based upon the order of the difference equation. Then substitute the values u naught, u1 and obtain. So if they given in the problem the conditions u naught, u1 given, obtain u bar z by substituting those as Z transform of un, and finally the required solution is un, means operating inverse Z transform of u bar z, we get Z inverse Z transform of u bar z will be un. Let's solve the problem now. We have the problem here, solve difference equation un plus 2 plus 4 un plus 1 plus 3 un is equal to 3 power n with the condition values u naught equal to 0 and u1 is equal to 1. So first we take Z transform of every term in the equation given. So that is Z transform of un plus 2 plus 4 Z transform of un plus 1 plus 3 Z transform of un is equal to Z transform of 3 power n. Then we use the shifting property. This can be written as z square because we have 2 here, u bar z minus u naught minus u1 z power minus 1. So you can also remember After u bar z we have to write two terms. Next 4 z transform of un plus 1. Here k is 1. So z. After u bar z one term u bar z minus u naught. Next plus 3 z transform of un can be written as u bar z equal to, we have in the right z transform of 3 power n, so that is z transform of k power n is z by z minus k. Here k is 3, z by z minus 3. Now so what you can do now, first we take u bar z is common out, so we have u bar z here, u bar z here, u bar z, so it gives the equation that is z square plus 4z plus 3. If you take u bar z common out, we get this. For the remaining term, we use the conditions given here. U naught is 0, u1 is 1. So substituting u naught is 0, we get this is 0 and this is 0. And u1 is 1, we have here u1, and multiplying this z square, we get minus z. Z square divided by z. So this we have z power minus 1, and we write the remaining z by z minus 3 in the right. So then this z square plus 4z plus 3 can be written as, this can be written as z plus 1 into z plus 3 and u bar z, and I'll shift this minus z to right. It is z by z minus 3 plus z. So taking LCM is z minus 3 in the right side, can be written as z plus z square minus 3z. So we get that u bar z is, in the right we have here z square minus 2z on simplification. So z square minus 2z, and divide by, if you divide z plus 1 into z plus 3 here, we get here z plus 1, z plus 3 and z minus 3. Now u bar z as a function of z we obtain using the shifting property. Now this should be resolved into partial fraction as previously you learnt. This is a by z plus 1 and z we have to take, b z by z plus 3 plus c z by z minus 3. So taking corresponding term in numerator, we consider the partial fraction. Now we need to find the values. Before that, let us divide by z. We get here z minus 2 divide by z plus 1, z plus 3, z minus 3 is a by z plus 1, b by z plus 3 plus c by z minus 3. Next, we take numerator in both the side. Z minus 2 equal to a into z plus 3 into z minus 3, b into z plus 1 into z plus 3, and plus c into z plus 1 into, for b I have to take z plus 1 into z minus 3, for c z, this should be minus z minus 3, we have to take z minus 3, and here z plus 3. So substituting z is minus 1, we get minus 3 is equal to a minus 1, we get like this, remaining becomes 0. So we get that a is 3 by 8. Next, substituting z is minus 3, we get that minus 3 minus 2 in the left minus 5. Minus 3 gives first and last 0. B is minus 3 plus 1 minus 2 minus 3 minus 3 minus 6. We get that B is 5 by 12. Next, we take Z is plus 3. It is 1 in the left. Then plus 3 gives C value. 3 plus 1 4. 3 plus 1 3 6. So C is 1 by 24. Substituting this all in the first step where you are resolving to partial fraction, you can write u bar z is a is a 3 by 8, z by z plus 1, b is 5 by 12, z by z plus 3, c is 1 by 24, z by z minus 3. So operating inverse Z transform on both the sides, we get un in the left 3 by 8. Let us make this is z minus of minus 1, means z by z minus k, where k is minus 1. So minus 1 power n. Next 5 by 8, 12. Same way here z by z minus k, where k is minus 3, answer is k power n minus 3 power n. Next 1 by 24, z by z minus k, where k is 3, answer is 3 power n. So this is the result. This is how you can solve the difference equation given. Let's solve another problem. We have difference equation here, yn plus 2 plus 6yn plus 1 plus 9yn is equal to 2 power n with the condition y0 equal to y1 equal to 0. So first we take z transform of on both the side of the given difference equation. We take z transform of yn plus 2 plus 6 z transform of yn plus 1 plus 9 z transform of yn is equal to z transform of 2 power n. So we use the shifting property. So we use this z square because the second order, y bar z minus y0 minus y1 z power minus 1. This is for first term. Next we have 6 times z transform of yn plus 1. It is y bar z into y bar z minus y0. Next plus 9 z transform of yn can be written as y bar z equal to, we have z transform of 2 power n can be written as z by z minus 2. So next we group the term of y bar z first, that is z square plus 6z plus 9 y bar z, and for the remaining we use the condition given y0 y1 both 0, so this is 0. So what remains now? In the right, z by z minus 2. So this factor can be written as z plus 3 whole square. Therefore, y bar z can be written as z by z minus 2 into dividing by this factor as z plus 3 whole square. Now we have y bar z as a function of z in the form of f of z divided by g of z. So we resolve into partial fraction here. So this can be written as, we have y bar z is z by z minus 2 into z plus 3 whole square. I'll resolve into partial fraction. A, first factor is z minus 2, corresponding term in numerator is z. Next I'll take b, since we have z plus 3 whole square, first I'll take z plus 3, corresponding term in numerator should be z. Next c, next term we should take z plus 3 whole square, the corresponding term. When you have z minus k whole square in the new denominator, corresponding term should be kz in the numerator. So therefore we take here where k is, what is k? If you observe z minus k, it is k is minus 3. So therefore term should be in the numerator is minus 3z. Nothing is changing in the bracket at the end. The same bracket should be retained. Now we divide throughout the equation by z for simplification. We get 1 by z minus 2 into z plus 3 whole square equal to a by z minus 2 plus b by z plus 3 plus c into minus 3 by z plus 3 whole square. So we can write from this 1 is equal to a into z plus 3 whole square, b into z minus 2 into z plus 3, then minus 3c into z minus 2. So we solve this for the values ABC by substituting z is 2, we get 1 is equal to a into 2 plus 3, 5 whole square is 25 and remaining gives 0. A will be 1 by 25. Next value z is minus 3, substituting minus 3 we get minus 3c into minus 5. So we get c is 1 by 15. Next we substitute, okay, I'll take comparing coefficient on both the side of z square. There is no z square in the left, coefficient is 0. Right side we get a coefficient plus b. Where a is 1 by 25, you can write b is minus 1 by 25. So we substitute all this in where you are resolved into partial fraction by considering corresponding term in numerator. So therefore our above equation u bar z become by substituting ABC where a is 1 by 25. So we have z by z minus 2 there. The bracket should not be changed. Okay, and b is minus 1 by 25 z by z plus 3. Next, C, you are substituting only to the constant. So you should not take any constant inside the bracket out. Okay, it is a standard format. We should be kept in numerator only. Because this is a kz. If you take minus 3 out, you don't have formula z divided by z minus k whole square. It should be kz divided by z minus k whole square. That's why minus 3 should be inside the bracket only. So now applying inverse z transform on both the sides, we get the result required is un is 1 by 25 z by z minus 2. So k power n, here k power n is 2 power n, minus 1 by 25 where denominator is z plus 3 can be written as z minus of minus 3 and k will become minus 3 power n. Next 1 by 15, this is kz divided by z minus k whole square format where k is minus 3. So k power n into n minus 3 power n into n. This is our final solution.